Morning, everybody. Welcome to chemistry. Here's our last video for this little section here. Today we're going to talk about if we have an acid, how we neutralize that. And the way that we remember right, we got an acid and we have extra H pluses in here, but we don't have the OH negatives. And the reason why we don't is because it came off the acid to make an H plus. We still have this chlorine negative here, but we don't have the OH negative that we would if this H plus came off of a water. So remember, when we have just plain water, we have the same number of OH negatives as we do H pluses, and then we have a pH of 7, which means neutral. But when we put an acid in, you can see right here that we don't get any OH negatives. And so therefore, we have an acidic environment with these more concentrated H pluses. Okay, so what do you think we have to do to neutralize this acid right here? Well, if we're going to have extra H pluses in here, somehow we're going to have to balance that concentration out with getting some OH negatives. Well, this is one way we can do it. We can put some base in here, and then when that dissociates, we get these OH negatives, and we don't get any H pluses because it's coming from water. We'll get, some sodium ions in there, but we won't get our H pluses. So if we put enough base into an acidic environment, then we can neutralize that environment. So we're going to talk about neutralizing with strong acids and strong bases. And the general formula is the molarity of the acid times the volume of the acid will be equal to the molarity of the base times the volume of the base. Which makes sense, since molarity, molarity is moles per liter. It's important that we also include this volume in the formula. Otherwise, we don't, we could have a swimming pool full of acid. We're not going to be able to neutralize that with a cup full of base. So that's why we have to have both the concentration here and the amount.
Rachel Newmiller to the attention.
Okay, so
please. Rachel
if we
Newmiller.
take a simple question. Here's the question: how many milliliters of 0.65 HCl do we need to neutralize 40 milliliters of 2 molar NaOH? Okay, and so we just simply use our formula, molarity of the acid times volume of the acid equals molarity of the base times volume of the base. We can just solve right away for our unknown, which in this case is the volume of the acid. So with just a little bit of algebra, we can see that the volume of the acid is equal to the molarity of the base times the volume of the base divided by the molarity of the acid. And now we can just really fill in the numbers. So the molarity of the base here is 2 molar. So it's 2. The volume of the base is 40 milliliters. Okay? And that's all divided by the molarity of the acid, which is 0.65. And then we can find that the volume of the acid we need to neutralize this is 123.077 milliliters. Okay? So if we have a basic solution and we need to neutralize it with the numbers I gave you, this is the volume of the acid that we will use, as long as the acid has this molarity of 0.65, and it's a strong acid. Okay, we'll do another one here. Okay, so there's just one more thing that we have to talk about. Let's say that we have H2SO4. And you can see here that this is the diprotic acid. So now for every complete dissociation of this acid, we're going to get 2 H's. So I got to show you how to put that into the math. Let's just say that we have 0.75 molar H2SO4, and we have 30 milliliters of that, and we need to neutralize that solution with 2 molar NaOH. Okay, so the question is, how much volume of NaOH do we need when it's that concentration? The difference between this one and the first one is they're using a diprotic acid. So it just changes the formula just a little bit. Really the formula is the same. It's the molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. The only difference here is this acid, you get 2 H's. And so for every 1 mole, you really get the action of 2 moles. So then it becomes 2 Ma times the volume of the acid equals molarity of the base times the volume of the base. And we're trying to solve for our volume of the base here, so divide both sides by the volume of the base, and we will see that the molarity of the base then, we want to divide both sides by the molarity of the base, since that's known. And the volume of the base then is equal to 2 times the molarity of the acid times the volume of the acid divided by the molarity of the base. And we'll put those numbers in here. 2 times the molarity of the acid is 0.75. The volume of the acid is 30 milliliters. And the molarity of the base is 2. And we'll put that all into our calculator, and we'll find out the volume of the base is equals 22.5 milliliters is what we're going to need to neutralize that diprotic acid. Okay, I'll be here to help if you have any questions.